Hello and welcome to this short video tutorial on lighting. So as we can see here, if we look out at our scene, we have, if we go into solid mode here, we will see we have 4 what are meant to be buildings, the ground, and then we've got our character inside a collision box. And this collision box has had its maximum draw type set to wire, which is important so that we're not casting shadows. We only have one light in the scene, which is this light here. So let's have a look at our lights. In order to see things properly before we examine the properties of this lamp, we need to change to texture mode when we're in Blender game, and we also have to ensure that we have this turned on, GLSL. So you can see the lighting is quite different in this mode here. So GLSL turns on the capabilities of your graphics card. You may also have to do this, so user preferences, and then under system, over here it says compute device, you can say CUDA and then turn it to your GeForce or whatever graphics card you have. You may not have an option to do that. It won't make a big difference for the game engine, but when later in the year we're rendering, this will make a very big difference. It'll speed up rendering times by an enormous amount. So you can see the graphics card that I have there, it's a 760. And if you're on a laptop, you may not have the option to do this. Okay, but for now, just make sure that you're on GLSL and that you change yourself to textured mode. Now, what have we got? We have got a point light. So a point light behaves a bit like a bulb. If we go over here to the properties window and have a look at its settings, now, so it has a color, so we can turn and give it a tungsteny light bulb color. It has an energy, so how bright and dark it is. It maxes out at 10. By default it starts at 1. We can tell at this distance here, this fall off distance is the distance at which the light, it says there, the light has half its original intensity, so 25 units. So at the moment we are measuring our world in nothing, in preset units. So if we go to meters, then this becomes 25 meters. So 25 meters away from this, the light will be half the intensity that it was. We can have negative lighting, so we can actually remove light from a scene, but for most of the time you won't be dealing with that. We haven't looked at layers in Blender, but it's possible to set up a whole bunch of layers and have, you can see that we have layers here. We can have lights affect only items that are on the particular layer that we're dealing with, or only on certain layers. At the moment all 10 layers are visible, so I could say with all 10 layers visible, this light should only affect items that are on the layer that it's on. So if it was on layer 2, it would illuminate everything that was on layer 2 but not anything else, which can be quite nice if you want to have sort of preset sort of lighting in a corridor or something. Anyway, so they're your basic settings, so you haven't got a lot, and the one thing you'll notice it doesn't have any settings for is shadows. So there are no shadow settings, and my mech here is not casting shadows. So let's hit P and play the game, and I can, walk around, and you can see I have no shadows. So what other types of light do we have? We've got sun, spot, hemi, and area. So we're not going to look really at hemisphere and area. Hemisphere does work in the game engine, but is basically half a sun, so we're not going to worry about it too much. Area lights don't work in the game engine, and if you wanted to make strip lighting or something, you'd use them. So the 3 that we're interested in are point lights, which is what we've got here, so like a light bulb, a sun, and a spot. So let's have a look at the sun. So the position of the sun is irrelevant to how it casts light. So it doesn't matter where this item is. So if I go in and if I move this to 60 rather than 6, it won't make any difference. Or if I go to 9 rather than -9, or so its position is irrelevant. All that's important is its rotation. Now at the moment it doesn't have any shadows, so if we turn this on, you can immediately see it makes a huge difference. It casts shadows. And we'll have a look at the settings for them in a minute. So now let's have a look at rotation. So if I press OR, I can change the direction that the shadows are being cast in. So if I want an afternoon game, so at sunset, I can play my game with shadows that are very long, like you would get at sunset. Now you probably saw there some of the shadows disappeared. So this panel here, the shadow panel, is responsible for the quality of the shadow. The two bias settings are basically for the internal quality of the shadow, and then the size is the main quality setting. This also will make a difference, these to the positioning of the shadow. So if I change bias here, you'll see the shadows start to move. Okay. You don't want them to move too much, because then when you press P and move, they won't actually line up with the object. Now, raising these levels and increasing this in size, you'll see it's 512, and we talked in class about bits and bytes and why it's 512. So if we make this 1024, the quality of the shadow will improve immensely, but it's going to take more processing. And keep in mind that this is a global setting, so this is not just for your player, it's for every object on screen. So that's when this layer only becomes interesting. So you could have your sun on one layer casts low quality shadows from buildings, for example, and then you could have on a different layer your player and its sun coming at the same angle, but have more or higher quality shadows just for that object. So that's a way to work with processing. This clipping there's clipping for the camera, there's clipping for lights, there's all sorts of so clipping is basically where the shadows begin and end. So anything closer than 50 centimeters won't cast a shadow, and then closer to the light, and anything further away than 40 meters will not cast a shadow. So there is sort of a range to how far the shadows will be cast. Okay, so spotlights. Well, a spotlight is, as the name suggests, a spotlight, and we can see its effect there. This one's not terribly bright, so we can increase the brightness. The shape is basically, is the shape of the cone, so how big or small the cone is. The blending is interesting. So if we look down here, we can have a hard edge here, or a very blended edge to the light. Most lights in the real world would have some sort of blended edge on them. Not always, but quite often. And you would normally use a combination of spotlights, point lights, and sunlights in a game. By default, the spotlight has shadows turned on, and as you can see here, if I press P, the shadow is not terribly accurate here. So we have the same sort of settings that we had before, so we may have to change these a little bit to tweak it for this spotlight. So that's a lot better. So just keep that in mind as you make your games. And lighting makes a difference between something that looks amazing and something that looks rather crude. So if I, with this game here, position this lamp so that it's maybe coming out of this lamp here, I change this to maybe a dark blue. I'm going to go Shift D, move this across a little bit, so I've got two of them, and I'm going to look in here at my my rig. I don't want to just parent them to the box, because that's not going to give me anything terribly accurate. So I'm going to select this bone here, and then when I parent the light to the skeleton, it will be parented when I select bone to the last active bone. So now I've got two lights there, that are my two spotlights, and then up here I'm going to add a sun. Okay, and I'm going to give it a very low angle to the horizon. Actually, we'll try it this way. We'll give it a very low angle to the horizon. This light will make slightly kind of pinky for sunset. Now we'll enable shadows. Okay. We'll up our quality. There we go. Now, so let's just see. Okay, so this is interesting here. So this box, we have to make sure that, so it's set invisible for the game, and we are going to give it a material. We're going to call this invisible, and we're going to go down here and tell it not to receive shadows, not to cast shadows, turn on transparency, and make it invisible. So now P. Okay, so here is our character who is pouring out. Don't worry about my disappearing mech in its animation, but we've got lights, and we have a long shadow cast from this this mech. So lighting can make a game very atmospheric. It can be the difference between a really good looking game and like a realistic sort of game, and something that looks terrible. So yeah, so be mindful of what you do with your lighting, because it can make a huge difference to how interesting visually your game is, and it can make a very good looking model look poor if it's badly lit, and it can make a mediocre model look excellent if it's lit in a particularly sort of broody or interesting way. So yeah. So you can make all sorts of interesting things, and the lighting system in Blender is quite effective. Last thing I'd say to you before we finish up is the amount of processing power it takes to cast shadows in real time is quite high. So while adding in one or two spotlights won't make a huge difference to your game, if you have a kilometer long street and you have each street light with a spot casting real-time shadows, you will definitely notice your frame rate dropping in terms of processing power. So real-time shadows, try and use them sparingly, as they can be a real drain on processing.